So law of conservation of momentum derivation, right? Yes. What this condition? Two bodies. One body we calling as A, and the second body we are calling as B. Mass of the first body is ma. Mass of the second body is m. Yes or no? Next. It is having initial velocity. First body having initial velocity, that we are taking as ua. Now this body, after moving, collide with the B body, interacts with the B. So the B body, second one is maybe moving, maybe rest. So yesterday we discussed the example like it is one of the striker, it is one of the coin. The striker is moving with the speed of ua. The coin may be rest, may be moving, but we are taking as rest. So the values will put it like that is u. This is the case I am taking here. This is the case we are taking for system of two bodies. System of two bodies before interaction. They are not collided. It is going to collide. A body is interacting with B. Not interacted. It is going to interact. So this is called system of two bodies before interaction. Now this is the place where the two bodies are getting interacted. So at the time of interaction, already we discussed what I discussed. This is called line of contact, and this is the line of action of force, and this is called as line of contact. Yes or no? So in this case, already we discussed what I discussed. A body applies the force on B, that we are calling as FBA, force on B by A. At the same time, according to Newton's third law, when first body applies the force on the second one, second body also applies the force equal and opposite, that is FAB, force on A by A. Both are equal and opposite because force is a vector quantity. Now after interaction, what is happens? At the time of interaction, what is happens? Whenever the force is acting, what happens according to the concept of force? You know that is nothing but rate of change of momentum, mv by t. Also we can write in terms of delta p by t. Rate of change of momentum is called as force. So here what is happens when one body interacting with other body? So force is going to exchange between the two bodies. So there is a change in momentum takes place with respect to time. So what way the momentum changes? When A body collides with the B body, A body collides with the B body momentum changes. At the same time, when B is applying the force on A, then A body momentum changes. So what is happening here? At the time of interaction, momentum is exchanging from one body to another. That exchange of momentum, due to that, what is happens after interaction? What is happens after interaction? The both bodies will move with the different speeds. Initially, the first body velocity is ua, that changes to va. Initially, the second body velocity is ub, that changes to vb. So that means same like striker coin. First coin is rest, striker is moving. After interaction, what happens? The striker maybe stops, coin anyway moves, or both are maybe moves. So but the speed may be different because first the coin is having 0 speed. After hitting, the coin gains the speed and striker loses the speed. That means both speeds are changes. That's why I am indicating as VA, VB. So what is not changes means? First case, the mass of the first body is ma, mass of the second body is mp. Before interaction, after interaction, at the time of interaction, whatever it is, always the mass will be remains same. Mass is nothing but quantity, quantity will not change. So our conservation of momentum relation we are deriving from this equation. What equation? At the time of interaction, if you see this one, at the time of interaction, FAB is equal to FBA. Using that one, we are going to solve. That is FAB is equal to FBA using the minus sign, opposite direction, according to Newton's third law. Using this one, we are going to derive the equation of that. Yes or no? So to solve this one, what I done yesterday? FAB, we are multiplied both the sides with the delta T minus FBA into delta T. Yes or no? FAB delta T is equal to FBA delta T.
About that.
FAB. This is B. Okay. To discuss this FAB delta T is equal to minus FBA delta T. Look at this formula once. What is t. This t is there in the denominator, you multiply it. So that means I can write this formula, f into t is equal to nothing but delta p. F into t is equal to nothing but what I can write? Delta t. So f into t is equal to nothing but delta p I can write. So f into t nothing but delta p means I can write FAB into delta t is equal to I can write as delta p of A
1 minute, sir.
is equal to second minus of FBA into delta t. Also I can write as delta p. That is something but delta p of BA. This is important to understand. Change in momentum of A, B is equal to minus change in momentum of BA. So here you need to understand what is delta. What is delta means? Delta means difference. Delta means difference. So here you need to understand the difference, means difference in the momentum. So in this case, okay, change in, this is called nothing but change in momentum. When force acting on A, this is what is the force acting on A by B. When force is acting on A, whose momentum changes? A momentum changes. When A slaps on B, B momentum changes. When B slaps on A momentum changes. In the same way, okay, delta P AB means A momentum changes. That means I can write the change in momentum I can write as final momentum minus initial momentum of AB. Similarly, minus PBA means this is also final momentum minus initial momentum of BA. So whose momentum changes? In the case of first one, A momentum changes. In the case of second one, B momentum changes. Force on A by B. Force on A by B means A momentum changes. Force on B by A means B momentum changes. So according to basic, what we taken momentum, we are indicating with the letter P. P is nothing but product of mass into velocity. Product of mass into velocity. You come across the case of first one, what we taken first, mass is NA. Okay, first body striker. The velocity of that one is UA. So momentum is PA. Right? Second body. What is the mass of the second body? MB. Initially, what is the speed of that one? UB. So the momentum is P. This is before interaction. At the time of interaction, what is happens? This momentum is exchanging. Again, the momentum changes. So in this case, momentum when changes, what is happens? UA changes to VA, UB changes to VB. In that case, what is the momentum of same body after interaction? Momentum of the same body after interaction is MA into speed of that one becomes VA is equal to nothing but I can write as PA dash. Before is PA, now new velocity, new momentum, so PA dash. Now second case, mass of that one is MB, mass will be remain same but speed changes UB to VB. The product is nothing but called as PB dash. Now apply these conditions in this equation. Now this is the equation for change in momentum for which body? A body. So A body final momentum minus A body initial momentum. What is A body final momentum? This is A body final momentum. So that is nothing but we can write as PA dash minus what is A body initial momentum? This is A body initial momentum, that is PA. PA dash minus PA is equal to minus of, now this is the case where the momentum of B changes. Momentum of B, that means final momentum of the B minus final momentum of the, initial momentum of the B. So what is final momentum of the B? That is PB dash. Write this. PB dash minus what is initial momentum of the B? That is nothing but PB. So PA dash minus PA is equal to minus PB dash minus PB. Now these terms you arrange it, that means A terms one side, B terms otherwise, okay, initial terms one side, another terms another side you arrange. First I am opening the bracket and after that I am solving this. Okay, look at this one, this I am writing as PA dash minus PA is equal to minus PB dash, minus of minus become plus PB. Now this is minus PA and this is minus PB dash. Okay, this minus PB dash, This minus PB dash, bring it to left hand side. This minus PA, bring it to right hand side. If you write in order, what you are going to get? PA plus PB is equal to this right side one I am writing as left side. Okay, so first PB plus PA plus PB is equal to this. If you make it this side minus, if you make it this, which one? This is minus PB dash. If you bring it this side, become plus. Already we have PA dash, so this becomes PA dash plus PB dash. Now this is called as law of conservation of momentum. What is the law of conservation of momentum? Stating that the total momentum of the system of two bodies, first body momentum PA, second body momentum PB before interaction, is equal to total momentum of the two bodies after interaction, that is PA dash and PB dash. Same, equal, it becomes equal always. Maybe they may have different momentums in separately, but the system having same momentum before and after. So total, the striker and coin total momentum before interaction becomes equal to after playing the caroms also, after interaction also, what is happens, the total momentum will be remains. This is a concept here. So what is PA formula I can write? PA is equal to nothing but, we can write now in terms of mass into velocity, that is MA UA, plus PB nothing but MB UB is equal to, what is PA dash? That is nothing but MA VA, plus what is PB dash? MB, that is VB. This equation is called as law of conservation of momentum. The total momentum of the two system of bodies before interaction is equal to after interaction. Okay. Applications of LCM, law of conservation of momentum. Only just we will discuss two for this level, and remaining levels will come in the higher levels. Okay. So the basic level is, first we are going to discuss about recoil velocity. Recoil velocity. So you see the gun firing, right? Practically, generally maybe you see in the movies, when you fire a bullet using gun, like this, bullet when moves forward, the gun moves backward, it will give jerk. Understand? The jerk is due to one of the concept of momentum. So what speed the gun is coming back, when the bullet is moving forward, gun will comes back. What speed the gun is coming back, that speed is called as recoil velocity. That is recoil velocity of the gun. So simply we can say velocity of the gun. Why we are calling recoil? Because it is coming in opposite direction of the bullet. Bullet is moving forward, it is moving backward, opposite direction of the bullet motion. That's why it's called recoil. Recoil means negative. Negative velocity of the any bodies we are calling as recoil velocity. Recoil. So in this case, velocity, recoil velocity means negative velocity of the gun. So how can how we can say, sir, it is negative? So to understand this one, always while applying the law of conservation of momentum, here how many bodies are there? While you are firing the bullet, what are the main two bodies? When you are using the gun, what are the main two parts of the gun? One is gun, yes or no? One is gun. The mass of gun is taken as capital. Mass of gun is taken as mg, otherwise gun, mg. And inside we have a bullet. Yes. What will be there inside the gun? Bullet. So the mass of the bullet is taken as small mb. Small m I am taking, that is I am writing as b. B means bullet, G means gun. So now before firing, concept how to apply law of conservation of momentum. Law of conservation of momentum always related to previous, at the instant of time, after, before, at the instant, after, like that. So that means before firing, condition, at the time of firing, condition, after firing. So anyway, here relation. Yes.
What did you write me in bullet?
Why we are?
The bullet.
Bullet is inside the bullet, inside the gun. First.
Mass into?
Mass of the bullet. B means bullet. G means gun. Okay, so in this case, before firing, what is the condition of the gun and bullet? After firing, what is the condition of the gun and bullet? Before firing, what is the condition of the gun and bullet? After firing, what is the condition of the gun and bullet? Right? To understand this one, what we are doing here, we are applying conservation.
Condition of the gun in
Condition of gun and bullet. Okay, so come to the case of derivation for this one. First, write the formula. Two body system is there. One is bullet, one is gun. So two bodies are there. Both are having momentums before firing, after firing. Because after firing, what happens? Bullet will move. So momentum changes. Gun also moves. Momentum changes. So two bodies, gun and bullet, both having momentums. They changed. So here we can apply the law of conservation of momentum concept for the system of gun and bullet. So what is the formula? Already just before we discussed, MA UA plus MB UB is equal to MA VA plus MB VB. This is the formula we learned in the previous. Now apply here for this gun and bullet. What is A means? First body. You take gun, that is mass of the gun. What is UA? Initial velocity of the gun. What is initial velocity? Gun is not moving. We are not fired. Before firing, it is speed is 0. Plus, what is the mass of the bullet? That is small m into small b. Now, what is the speed of the bullet? Bullet also not moving before firing. Both are not moving, so 0. So both are 0 before firing. Is equal. After firing, what is happens? The bullet will comes out from the gun and moves with the speed. That speed is we are calling as Vp. The speed is called as Vp. Now in this case, whenever the bullet is comes out, what happens? The gun will move backward. That is called as velocity of the gun. How can you say backward means? Using the derivation, we can able to explain that it will move backwards. So here, conservation of momentum before firing I applied. This is the equation. This is the way you get. After firing, if you apply this one, what is after firing? What is the mass of the A? That is nothing but gun, mass of the gun. What is speed of the gun? We don't know, that is you take it as Vg. Because after firing, gun will move. Practically, it is moving backwards. So I can say some value with some value it is going to move. That is Vg. Plus mass of the bullet, that is Mb. Into what is the velocity of the bullet? That is Vb. It is moving forward. This is the way you have to write. The total becomes how much? This value 0 into anything is 0, that value becomes 0. 0 is equal to mg vg plus mb vb, you will get. So I want to calculate the velocity of the gun, that is we are calling as recoil velocity. So I can write this one as mg vg is equal to this. If you bring it this one towards the left, it becomes minus. So that minus I am applying to the other term. So I can write as mb vb. Minus I am applying. In just minus nenu outside this right side daniki apply chestu. So mg vg is equal to minus mb vb I can write. Our requirement is vg. What is vg? That is minus mb vb by capital M vg. So this is the formula, relation we are getting when bullet is fired from the gun using law of conservation of momentum concept. Here what is this minus sign? This minus sign indicates the direction of the gun. What direction is moving? Minus means it is moving in negative x-axis. Second application is ballast bomb, right? That means you consider one bomb having mass m. Initially it is placed in one place, grenade. The speed of this one, it is not moves, no? What is the speed? 0. That is called initial speed of the bomb. Now what happens when bomb blast? Imagine that it splits into number of small parts, fragments. We are calling as fragments. So here we are not taking the complicated discussion, we are just taking the simple discussion that this mass body splits into two equal parts. Question will come 2 equal part, 3 equal part, 4 equal part, n equal part. So that will be according to your level of understanding. So basically 2 equal parts. So first part is called as, this is small m, second part is also small m, because I said both are equal parts. So to that bomb having capital M, before blasting speed is 0. After blasting, what happens? Blast means what happens? The particles, the partition particles will move away. So in this case, this small m, both will move opposite direction. Both particles, this is the way if you say bomb, when bomb blasted, both will
What are
move
those both small m's?
opposite direction. Yes.
What are those both small m's?
What are the small m fragments? We are calling as fragments.
Sir?
Fragments we are calling fragments.
Fragments in bomb.
Fragments means pieces. Fragment means pieces. A bomb when blasted into pieces, that is called fragments. That is two fragments. So in this case, what happens? The first, otherwise if you want to indicate this one like 2, m1, m2 you take it. So m1 moves with the speed v1, m2 moves with the speed v2. Like this you take it. Apply the concept. What is the speed of the second fragment? What is the speed of the first fragment? What is the mass mass of the second fragment? What is the mass of the first fragment? మనకి క్వశ్చన్ ఎలా అడిగితే అలా చేయాలి. వాట్ వే ద క్వశ్చన్ ఈజ్ ఆస్క్డ్ అకార్డింగ్ టు దట్ వన్ యూ హావ్ టు చూస్. బట్ కాన్సెప్ట్ ఈజ్ సేమ్. వాట్ ఇస్ ద కాన్సెప్ట్? బిఫోర్ బ్లాస్టింగ్, ఆఫ్టర్ బ్లాస్టింగ్. సో here two system, two particles, two fragments are there, means two system of fragments. So I can take, so I can apply the law of conservation of momentum. What is the law of conservation of momentum formula? MAUA plus MVUB is equal to MAVA plus MVVB is the formula for it. Yes or no? Apply this formula here. What is MAA? First, in this case, only we have one body. There is no two bodies. So totally I can take it as m into 0. Total momentum of the single body system, m into 0, is equal to. After that, it becomes into two pieces. What is the MA? MA means first one, m1 you take. Speed is v1. Yes or no? Look at this one. Next, second body is m2. Speed is v2. So using this one, m into 0 anyway, 0 totally. So that 0 is equal to m1 v1 plus m2 v2 I can. From this what I can write? m1 v1 is equal to, becomes minus m2 v2. This is the equation you are going to take. If you observe this equation, what is mass into velocity called as momentum? The momentum of the first fragment will becomes exactly equal and opposite to second fragment. So that means both will move exactly always opposite direction. When single bomb splits into two parts after blasting, both will move exactly equal with the equal momentum opposite direction. If the masses are same. If the masses are not same, then momentum values may be different, but always they will move in opposite direction only. So that means P1 is equal to minus P2. This is the way you can derive the equation. If you want to calculate any one of the speed of the fragment, suppose I want to calculate the second fragment speed after blasting. Second fragment speed means V2 I want. How to calculate V2? From this equation. From this equation, V2 is equal to, this already we have m1 v1 this side. m1 v1 by this total minus m2, make it this side. That becomes minus m2. So if you write in order, m2 is equal to what I can write? Minus m1 by m2 into v1. This is the way you can write the equation. This is called velocity of the second fragment. If you want to write the velocity of the first fragment, I can write from the same. v1 is equal to, I can write as minus m2 by m1 into v1. v2. Look at this one. Just reciprocal. If you want to write this v1, then this total minus m1 by m2, make it this side, becomes minus m2 by m2. This is the way you can able to apply the concepts in the problems. Understanding. What is the main point? Understanding before the system, after the system of interactions. Before firing, after firing, before blasting, after blasting. That is the way when you observe the any physics concept, you have to apply the law of conservation of momentum concept. Is it okay?